Hello ladies and gentlemen, welcome back to C.A.R. Entertainment. I'm your host Alan Hamilton, guys, and today we're going to be moving on with our 821 digital technology revision videos, guys. And today we're going to be talking about databases. This is really the whole big thing so far in digital technology. What we've done is about databases. We talked about data modeling, which was all about databases and relational databases, normalization with databases. A lot of our videos in the upcoming times will be about databases, but let's actually talk about databases as a core first, so you just have a general understanding of them. So we'll talk about what is a database to start off with. Well, a database is a collection of data items that are structured so that the data can be searched and retrieved when necessary. There's different types of databases that you can use. The first one is called a flat file database, and this is where the entire database is stored in one single file with one row for each record and one column for each field. The data will be repeated unnecessarily, and therefore this is not an efficient database. Each record is made up of, so a record is a set of fields, and a field is represented by a column in the table. You'll know this whenever you go into software packages like Access. This will be a lot more clear. So a flat file database will show things like data duplication, which is whenever there's duplicate copies of data that waste storage space. Data will become redundant or it will be unnecessarily repeated. It will also show data inconsistency, whereas the more often you have to key in data, the more chance an error will occur in this data entry. And because you're always entering a new record in a flat file database, this is quite likely. You also may get poor data integrity, which is whenever data is erroneous or inconsistent and therefore it is not reliable. But then you have a relational database, and this is much better to use because this allows the data to be spread across a number of tables. The tables will then be linked and or will be related to each other using relationships on common fields. These are linked by primary keys. We'll get into that. Each table must have a unique reference called a primary key, where every single person or every single field will be different in this table. Therefore, this is the primary key. So, for example, you might have a table called product. Product ID is going to be a primary key because every single product ID will be different. So, therefore, a primary key is a uniquely identifier in the table. It uniquely identifies each record in the table. If you replicate the primary key into other tables, it will then be called a foreign key. So if you have a product table with the product ID in it, that's the primary key in that. But if you then have an order table with the order ID in it, then that's the primary key in the order table. But then if you put your product ID into the order table as well, then that becomes a foreign key because it is the primary key in the product table, but it is also in the order table, and therefore it's known as a foreign key. And this foreign key then is used to form the relationship that links the tables together. So the product ID, it can go back and forth, so it knows that these two are related. And therefore each record is uniquely identified by the primary key in the by a primary key field, and tables will be linked by a primary and foreign key. A relational model will have each data item only stored in one location, and that will be the table. So let's go on to talk a little bit about data redundancy. Well, the duplication of data is called data redundancy whenever you duplicate data, and this is kept to a minimum in a relational database. And this is because a relational database has more than one table of data, with keys joining tables together, such as a one-to-one, and this is whenever each table contains one unique record. One-to-many is when one table may contain records about an individual and have other records about the individual's finance transactions. That's essentially what I was on about, where a one-to-one is where like you just have the primary key and no foreign keys in it, or a one-to-many is where you have that primary key and many foreign keys in it. A database can have constraints and access to it, so you can constrain input into your database, and these constraints will help control the data integrity, and they can prevent entering text where a number is expected for your data type, or having two products with the same project ID, and this can be done through auto number. So these features will allow you to set field properties, set constraints, and increase the reliability of data and reduce data redundancy. You then have access rights, which are operations that a user can use, and these include select, insert, delete, alter, and create. And these rights correspond to operations performed using SQL or structured query language, and we have a dedicated video for SQL and QBE, which is query by design, or SQL. But we are going to touch a wee bit in SQL now. You just need to know the three main components, and that is that select. The select command means you're specifying data to be displayed, what data you want. From is in you're identifying the source of the data, so you're selecting the data you want, where's it from, where's it coming from, and then where, so you can add a little bit of criteria. So you can select the product ID from the product table where product IDs are over 5, for example. So that gives you all the product IDs that are over 5, just for an example. So This then means all databases allow the owner to create, read, update, and delete data, and this is done through SQL, and it's a language that allows users to query and manipulate data, protecting from unwanted updates, deletions, or potential errors. But of course, we will go more in depth in this dedicated video. Portability and relationships is next up. Portability is using the relational model as it ensures data is transferred between relational database systems. And this is, you have relationships and cardinality, which we talked about in data modeling. Whenever we talked about making an ER diagram, you have all these like crowfoot notations thing. So you have your one-to-one, your one-to-many, and your many-to-many relationships. And cardinality will show the max number of occurrences that can be involved in a relationship. Now we're going to talk about referential integrity and some key terms you need to know. So referential integrity ensures that data in one table will not contradict data in another. It means essentially that whenever you insert data, it will only be allowed if the pay grade exists in the pay table. So we're going to use that for example. We use a pay table, and let's say there's a pay grade column for an example. You can only insert in there if the pay grade exists. If the pay grade doesn't exist there, you won't be able to insert anything into it. The deletion or update will only be allowed if the number of employees are on that pay grade. So if there's no employees on that pay grade, if that pay grade exists but no employees are on it, you can't delete someone from that pay grade because they don't exist. You can also change the value of the pay grade in the employee table by updating it, which is only going to be allowed if the value exists. So again, that pay grade has to exist in the pay table for you to update it. You then have different key terms such as an entity, which we talked about when doing our ER diagrams. An entity is an object or a subject about which information is stored, such as a member. An attribute is about this entity, and it can be like essentially what your column name will be. So it's like your title. So each data item within an entity, such as title in a book. So if you have your book table, then you have title, author, all out there. Those will all be attributes. And then you have a composite key, and this consists of two or more key fields, each of which may be a primary key in another table, which will uniquely identify an entity occurrence, such as a member ID plus a book ID. And this is essentially just where one table has two primary keys in it. So therefore, it's one table with two foreign keys. A composite key is just essentially two foreign keys in the table. That's essentially what it is. Thank you for watching the video. I'm Dylan Hamilton from C.A.R Entertainment, and I'll see you next time.